Okay, so chapter 4, conceptual stuff, review stuff. The idea of action, reaction, pairs. So in our notes, in our discussion, we talked about how for every action there is an equal and opposite reaction. Briefly, if you pick up your pencil and you throw your pencil, here's your hand. It's pretty deformed looking. Here's your pencil. You exert a force on that pencil. That pencil exerts a force back on you. You know this. Why does the pencil go forward and you don't go backward? Nope. The force is equal.
Why don't I go backwards?
Yeah. Why don't you fall over backwards? The pencil goes shooting across the room. Okay. Remember this. Yeah. You're a lot more massive than the pencil is. So if you stand up and jump on the surface of the earth, when you land, the earth exerts a force upward on you. You exert a force downward on the earth, too. Does the earth move? Why? Huge. Much more massive than you are. So, the force, the earth is, you are exerting as much force down on the earth as the earth is exerting on you. But the earth doesn't shift because, it's more massive than you. Does that make sense? Okay. It's pretty easy.
Okay.
I do not care if you know which is Newton's first, second, and third. I care that you know what they mean. So if we talk about inertia, do you know what that means? If we talk about the force that an object doesn't accelerate unless it is acted on by an unbalanced force. I care that you can apply them. I can never remember which is 1, 2, and 3. Who cares? You can look that up. So, okay, other questions?
Satisfactory.
Okay.
Is there more?
Give me an example of a contact force.
Car hitting a school.
Wherever did you get that example? Okay, so contact force, it's two objects touching, one exerting a force on the other. So, sure. I'm glad you can laugh about it. Give me an example of a field force.
It says like electricity. Can't say it more or less, but it's a field.
Electromagnetic fields. So
Yeah.
a magnet exerts a field force on a paperclip. They don't have to be touching to pick the paperclip
Well,
up.
what happens when they touch?
Then you have contact forces and field forces. The field force is still acting even when they are touching, but the field, gravity is still acting on me even though I'm touching the ground. I'm this, and the physical structure that I'm touching is linked to other things which are physically touching the center of the earth. Gravity is still a field force. So, and gravity is the one that we've talked about most. Because whether you're above the earth or on the earth, gravity's acting on you. Here's the part to not forget about that. If I have this little car going down the road at constant speed and constant direction, not accelerating, so A equals 0. The minute this car turns, acceleration has happened, right, because that velocity is both speed and direction. Okay, you got that.
I always bomb these ones because
You have to really read carefully into the questions, and they're challenging. So, yeah. Okay.
I will find it.
Okay.
Is it possible for an object to move?
Poorly worded, I think. I didn't write the textbook. Can an object move if no net force is acting on it? Can it move if no F net? It could be moving, and it could continue to be moving if there's no F net, if they're all balanced. It could be moving at constant velocity. but I don't think that's what they're saying.
But constant velocity could be 0.
Well, 0 is a constant. It could be moving at constant v. Yes, 0 can be a constant velocity because it's 0 velocity, but so could 10 meters per second, so could 6,000 meters per second. Still constant velocity. But I think what they're saying is, could it start to move if F net equals 0? No, it can't change its state of motion if F net is 0. Can't change state of motion.
And then, as this one said, if an object is at rest.
If an object is at rest, can we conclude that no external forces are acting on it? What's your answer? No. Now, can we assume that there are no unbalanced external forces acting on it? Yes. But if it's at rest, it probably still has some forces acting on it.
Yeah.
You know. Yeah.
At this point.
Is there an unbalanced force acting on it? Is its acceleration 0?
No. Oh, well, it's all the way up here.
Yeah. Is its acceleration 0? Its velocity is 0. Is its acceleration 0? Tricky, tricky. They are, I know. Wait till we get to the spring and wave stuff where the math is like stupidly easy. The math, you know, a third grader, okay, not a third grader, but the math is ridiculously easy. The concepts are brutal. It flip-flops, I know, I'm sorry. So the truck is going forward, where's the ball going to go?
Backwards.
Yeah,
So they want to stay
because it wants to stay right where it is, and the truck's, basically, the ball is staying here and the truck's moving away from it. The truck is moving out from underneath it. The ball wants to maintain its location. It's at rest, it wants to stay at rest, it wants to stay in position. That would be inertia, right? Yeah, that's inertia. So 4A is just net forces. So we're just finding net force. We're not worried about the mass acceleration. So, you know, there are three basic kinds of problems here. You've got, you know, things where you've got all these different forces acting on an object, resolve all the vectors. Oh, let's see, we got this, and we got this, and we got this, and add them up, and, you know, find the net force, which is just going to be, you know, F net equals square root of Fx total squared, Fy total squared, and it's just bookkeeping. It's an accounting problem. It's keeping track of, oh, well, Fx total is equal to Fx1 plus Fx2 plus Fx3, blah, 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 you know.
When I do this, I automatically, like, I'm always thinking of the last problem I did. It's like a 4D problem, like, M,
Right.
but M is 0, so it's not really there. And I'm just like,
Right. Well, and that's where you have to learn to separate that in your mind, you know. So, you know, this is one of the subsets of 4A problems where you've got a bunch of different forces, and this is just like the non-perpendicular vector problems, which everybody hates. It's really just accounting. And anytime you see a problem like this, the question is going to be, what is the net force? So anytime it just says what's the net force, if nowhere in the problem does it talk about acceleration, you've just got a bunch of forces listed, you're just doing this kind of thing. The other things that are net force problems are things on cables, just hanging there, like Tinkerbell today. You know, if it's just hanging there on cables, that's a 4A kind of problem. And it's just sum of forces, and usually we're asking, oh, now that would be a really good one. It's too late. I'm like, I can't add it to the test now, I don't think. To have an object to give you the force of tension and ask you what the mass was. That'd be a great problem for next year.
for next year.
For next year. You know, like I said, too late. I've got the test mostly written, so too late. But, you know, you're just resolving vectors and doing a sum of forces. So that's a little bit different than this kind of 4A problem, because here you're not solving for something using a sum of forces. You're just coming up with the sum of forces.
I'm nervous about these ones because once in a while I mix up the south
Sign-
and west.
Oh, okay. But you know what? If you do your heading and you reverse your coordinates, like if you have the correct angle and you just reversed, south of east versus east of south, you're going to lose like 3 points on your heading. I mean, the whole heading's worth 4 points. You'll lose 2 or 3 if you just flip those, if you have the correct degrees, and you show your work so that I can see that the angle, I'm trying to think of okay, there's no way to do this without doing this. If you're showing let's shrink this, or at least get it out of here. If this is 10 and this is 6, and you're getting this angle theta, if you're showing me, well, theta equals inverse tangent, opposite over adjacent, 10 over 6, but then you proceed to call this, west of north, not north of east, but I can see through your math, we are talking about this angle, you're not going to lose all your points for your heading. Because you've laid out the steps. I can see that we are talking about the same angle. You are getting the calculation the same way. You just reversed the heading. So.
I don't know. I did that problem. I redid the A, and
Okay.
I just misread it. I put it like southeast. It was supposed to be northwest. And I just completely blew out of proportion. Killed it. And my X was wrong, but my Y was right. And I was like.
Okay.
I missed probably over half of my points, more than half of my points, because my whole problem was messed up.
Because, and if you do that in an early step, where it throws off your other calculations, then yeah, you do lose more points. If you only do it at the end and you've got the correct total Y, total X, and you're just getting your heading wrong because you flip-flop your directions, that's not a big deal. If you're screwing up your X and your Y and you're missing these, then yes, it does lose you more points. So, okay, so we've got those kind for 4A, we've got this kind for 4A where you have cables. Really the only other kind of thing for 4A, like we had people holding pumpkins, people holding washers, people holding things, or people just standing there. Where you've just got a free body diagram. So those are 4A. When we get into 4B is where you start to see that the sum of forces on at least one axis, either X or Y, is not equal to 0. So we have, and let's get rid of that now. It's equal to an MA, which is not 0. And in the 4A problems, it's either equal to 0 or we're not talking about the acceleration. And this is the thing that you've struggled with, is remembering that no matter, and if it helps, here's a thought. If it helps you, because your problem is that you tend to just forget about that MA. So, in these, it's equally true that sum of forces on the Y is equal to MA. Write that. And then you can just say to yourself, oh, well, it's equal to 0. So, if that helps you, because that's the thing you keep doing. It's so funny. People do have signature mistakes. I've got 3 people right now in physics who have very distinct, very unique signature mistakes that they have made on quiz after quiz or test after test or homework after homework. This is yours. You keep forgetting that thing. So maybe you have to write that.
I get so happy when I remember it. I'm like, yeah, that's it.
Yeah.
I feel like a little cheer in my mind. It's kind of scary.
That's okay. That's fine. Okay, so that might help you, is just always writing that regardless. Here typically we're now involving some amount of acceleration on that axis, so we can either solve for acceleration, we can solve for mass. We can solve for other things, but we just really have one more variable to work with. Okay. So for C and D, the tiers, they're awful. I know.
Well, on the set, but
Good. On the 4, yeah, you did. That's right. That's right. And you actually did better on these on the mixed FIP today, didn't you? Okay. They're fresher. They're fresher. Basically 4C solving for mu values, 4D everything else.
everything.
Everything else. Pick it. I mean, the learning goal, if you look at PB Works where I've got all your learning goals up, I think it says, solve for any variable in a situation involving sums of forces on 2 axes in addition to coefficients of friction. Everything else.
Yeah.
So
What's chapter 5 like?
let's not talk about that just yet.
I can have some happiness right now.
Yeah, have some happiness. You'll have fun building your bridge.
Okay.
You'll have fun building your bridge. So, it's good.